Hello everybody and welcome back. We're taking a look here at question number 16 on the 2004 grade 11 multiple choice. That's the Fermat competition. And what have we got here for question number 16? A right-angled triangle has sides of length 6, 8, and 10. Yeah, that's a Pythagorean triple that everyone should be comfortable with, especially on the grade 11 paper. A circle is drawn so that the area inside the circle but outside the triangle equals the area inside the triangle but outside the circle. I think a picture will help clear this up. We'll draw that in a moment. The radius of the circle is closest to. Now, as soon as they say something like closest to, I'm thinking we grab our calculator. Not always. I've been fooled in the past, but usually it's grab your calculator time. So we're going to warm that one up. It's questions like this that are the reason to make sure you do bring your calculator. Okay? Other than that, I know you guys know that I try and just avoid calculators when I can, and we'll see what we can do here, but warm up your calculator because you might need it. Okay. Alright, so area inside the circle but outside the triangle equals the area inside the triangle but outside the circle. So let's get a picture going on here. That's not a terrible circle. Now, the thing is, with the picture they've got there, we just have some overlap. We actually don't know how much overlap. They've given us a certain amount. But if you reread the question, the overlap amount doesn't actually matter. This doesn't quite look like their picture, but yeah, they have a sort of a secant going on there, or a chord. But it'll all work out fine. So the idea is there's some overlap here, and the area inside the circle but outside the triangle is the same as the area inside the triangle but outside the circle. And then there's this wonderful blue overlap. Okay? So it doesn't actually matter how much these guys are overlapping, if at all, because we've got sort of this red Pac-Man slice plus the overlap between the two is equal to the area of the circle. But the overlap between the two and the area, the other red area, these two red areas are equal. We get this blue overlap slice is the same in both. But now, if we add it up this way, the missing piece of the triangle and the overlap area added together give me the area of my triangle. And I know the side lengths of my triangle. So I can, since it's right angled, I got a base of 6 and a height of 8. But because these two red areas are the same, this actually means area of circle must be equal to the area of the triangle. Okay? We don't need to know how much overlap. In fact, it doesn't matter how much overlap. The equations tell us area of the circle is equal area of the triangle. So if we maybe gave the circle a radius of r, and we do want the radius of the circle, we want to know the radius of the circle is closest to. So the area of the circle, which is pi r squared, should be equal to 1/2 base times height, the area of the triangle. This is going to be 1/2 of 48, so 24. So r is basically going, well, r is going to exactly be the square root of 24 over pi, just rearranging this equation. And yeah, I can't do that. Sometimes I can try and approximate these things in my head, but we're going to have to grab our calculator. So this is a prime example of why you should bring your calculator when they're allowed. 24 divided by pi is about 7.63. And then if I want to square root that, I get about 2.76. Okay, so we're going to write that down. 2.76, we'll put a 3, the next one's a 9, so I'm going to round that 3 up to a 4. Not that it particularly matters. The answers I believe they gave us were to 1 decimal place. So it's going to stick out. Really, the 2.8 is the only thing we could have here. All right, 2.8, so that's rounding up to 6. So this is going to be an answer of Okay. Not a bad question indeed. I kind of liked that one. When I first saw this, and I mean first, like way back when, I was very confused by this one because if you look, the triangle is not really in the circle in any meaningful way. And that did throw me off, and that's why I mentioned it a couple times, that the actual picture we drew and the picture they have, it reflects the situation, but they don't have to be exact because it's all about the fact that you realize, oh, the overlap space plus the extra bits either equal the circle or the triangle. Since the extra bits in both cases are the same, it's the same thing. But it can certainly throw you because it's not as exact as some other geometric construction questions, like, say, question 14, where they tell you E is on AB and things like that. Or some of the other things that you might expect having done a bunch of these contests. Or whatever 23 is, I'm sure it's a bit more exact. Whereas this is just some overlap. Anyway, that's question 16. If you would like to, join me for question number 17 in the next video, and I'll see you there.